Hi guys, this week we are talking about chemical reactions. Just as a reminder, the important vocab words from this video are highlighted in yellow. Before we get started, let's do a quick review about what we talked about before break, which were physical and chemical properties. So a physical property is anything you can observe without changing the identity of a substance. These are things like phase changes, melting point, the point at which something melts, or boiling point, the temperature at which something changes into a gas. What's really important is that different substances have different melting and boiling points. And so if you have an unknown substance, you can use melting points or boiling points to try to figure out what that substance is. So if you have an unknown metal, you can try recording the temperature at which it melts, actually heat it up, and then you can match that melting point to the known melting points of different metals and figure out what it is. Density is another really important physical property. It's the mass divided by the volume. Same thing, every substance has a unique density. And so if you're not sure what the substance is, you can use density to try to figure out what you actually have. Same thing with shape, size, color, and smell. Of course, these aren't the same as density and melting point and boiling point, where everyone is unique. There are a lot of elements and substances that are the same color, a lot of clear ones, but they will all have different densities, different melting points, and different boiling points, as well as different freezing points. That wasn't on there, but that's another one. This image here is just showing you some different liquids and solids and their densities, and showing how the most dense things are down here and the least dense are up here at the top. The other type of properties are chemical. They can only be observed through reacting, and they actually will change when you test them. They'll change the identity of the substance, so it will either be destroyed or it will turn into something else. When I say destroyed, what used to be that substance, that actual matter, is not destroyed, it's converted into something else, usually a gas. So it might look like it was destroyed if you burn a piece of paper, but the matter still exists, just in the form of gases. One example of a chemical property is how reactive something is with oxygen. Substances burn when they react with oxygen. They react quickly to produce a lot of light and heat. That's fire, of course. Things like these metals up here are reacting to oxygen as they're burning, and they are burning different colors because of their chemical properties. This is the reason that if you cover a flame with a glass dish or put the top on a candle, it will burn out, because what's happening is that wick is just reacting with oxygen to produce the flame. Another way things can react with oxygen is through rust. That's a very slow reaction with oxygen. pH is another chemical property, which we talked about when we did the hydrosphere. So of course we have our neutrals, which is 7, acids, which are the low numbers, and alkali or basic, which are the higher numbers. Of course you want your water to be right here at 7, neutral, so it will have high water quality. What we didn't talk about before was that acids and bases react with water and they release ions. So the acids will release hydrogen ions when they're with water, and the bases will release hydroxide ions when they react with water. If you react an acid with a base, you'll end up with a neutral solution if the acid and the base were the same strength. And that's because this H plus ion wants to react with this OH minus ion to create, you guessed it, H2O, water, which is neutral. Just so you can see the difference, here's an example of some common substances. Some are compounds, some are elements, and their physical properties here, like their density, how they look, their color, their shape, their boiling point, and then their chemical properties over here. So how reactive are they? Are they flammable? What do they react with? Notice that to find out all of these chemical properties, you would have to actually do a test on these things that would cause a chemical reaction. So to know that something's flammable, you would have to light it on fire. And to know that something does not react with vinegar, you would have to try to react it with vinegar. Not true with physical properties. This is also a review from last time. You already know that physical changes do not cause the actual substance to change, while chemical changes do. So this slide tells you some examples of both those types of changes if you have forgotten. Now here's the new stuff. So a chemical reaction is just another word for a chemical change. Two or more substances, they could be elements or compounds, are reacting to form a new substance. Notice that they will not be mixtures, and that's because mixtures are physical combinations of elements and compounds. Elements and compounds are your chemical bonded substances. In every chemical reaction, you will have reactants and products. The reactants will always be on the left, and the products will always be on the right. Think about the reactants are what you're putting in, what you're reacting, and the product is what you're making and what's coming out. You also sometimes might see reaction abbreviated RXN. That just means that's the reaction. There's not only one type of chemical reaction, they fall into four main categories. And that's synthesis, something's being made, decomposition, something's breaking apart. So let's hear this is broken apart into just A and B. Single replacement, so something switching places. Here the B switched with the C. And double replacement, so two things are switching places. So C and B switched. There also is a fifth type, combustion, where something is being burned. There are a few key ways to know that a chemical reaction has happened, but be careful because there are exceptions to every rule. So one sign of a chemical reaction is a color change. That would be like the iron has rusted. Not a chemical reaction is adding food coloring to something, like we did for rock candy. So that was a physical change, but if something is reacting to change colors, that's chemical. Temperature change, when something combusts or catches fire, that is a sign of a chemical reaction. However, boiling water or freezing something is not chemical, that's physical, because remember, evaporated water is still water, just in a gas form. That's physical. Formation of a gas, it has to be a new gas. So if it's just water turning to water vapor, that's physical, it's not a chemical reaction. But if it's a new gas that's being created, that's chemical. And formation of a precipitate. So when we talked about rock candy, we talked about how precipitates are solids that fall out of a solution or are caused when there's a single replacement that makes a new solid. So when something is just coming out of solution, like our rock candy, that would have been a physical change. But if a new solid's being created, a new precipitate, that would be chemical. Reactions also can occur at different speeds, and that's called the reaction rate. There are a few ways that the reaction rate can be adjusted. One is by changing the concentration of the reactants. Concentration means how much there is. So if you have more reactants, then the reaction can occur for longer and for faster. Changing the temperature, usually if you make something hotter, then the reaction will occur faster. If you cool something down, it will go slower. Surface area of the reactants, so if you have a larger area where the reactants are, not a higher concentration, but just a more spread out area, there's more particles that can collide and the rate will increase. And the presence of a catalyst. A catalyst is something that speeds up the reaction. A great example of this in your body is an enzyme. They help you break down your food at a rate that keeps you alive. Without them, you wouldn't be able to survive. Digestion is a great example of a chemical reaction that occurs in your body all the time. All right, that's it for this time. I will see you next week. Have a great one. Bye.